We are going to study now what are Kirchhoffs rules. Now, in order to solve complicated circuits, we use Kirchhoffs rules. If suppose you have a simple circuit where there is a battery and a resistor is attached and there is another resistor, and suppose there is another resistor here. So if you have to solve this circuit, it is very easy to solve this circuit by using these two resistors in parallel, get the total resistance, and then the total of it and this R1 will be in series. And so you can calculate the current through these resistors, and so you can solve this circuit very easily. But if on the other hand, if you have a circuit like this, where there are two batteries involved, or maybe some other elements also like this. Okay, so if you have a circuit like this which is complicated and it has two batteries, and you don't know how, and we don't have any rules where we can add resistors in such a manner. Like here, simply we just have to use the resistor addition rules by series and combination. But in this case, in order to solve such circuits, we use Kirchhoffs rules. So in order to solve this circuit, Kirchhoff was a scientist who has given two rules, which are as follows. The first one is a junction rule. Now, the junction rule is for charge, and it is based on conservation of charge. It means that charge will not be dissipated anywhere, and it will just flow from one wire to the other. So this junction rule states that the total current at a junction is equal to 0. So what is the meaning of this now? So now let's say that current is flowing through this wire, and then there is a junction here, and so some of the current flows along this side. There is some current that may flow along this side and some current that may flow along this side. So now if the current here is I1 and current I2, and here it is I3 and here it is I4, then this current will be equal to this plus this plus this. Okay? So wherever there is a junction, so if I have to write this equation, it will be I1 will be equal to I2 plus I3 plus I4, or I can also write it as I1 minus I2 minus I3 minus I4 is equal to 0. So it means that the total current in a junction, at a junction, is 0. Okay, it means that the amount of current that is entering the junction is equal to the amount that is leaving the junction. So that is why we say it is conservation of charge. No charge is lost at the junction. It is just moved from one wire to the other. This is what it means. Okay. So the second rule is, it's called the loop rule. And loop rule is based upon the conservation of energy. This rule means that if you have a loop, suppose you have a simple loop, let's say there's a battery and a resistor and another resistor. Okay, so in this loop, the total potential difference will be equal to 0. So suppose now that in this battery, this terminal is at 0 volt and the other terminal is at 10 volt. Okay, and you have a resistor R1 here and a resistor R2 here, and the current will flow in this direction. So this rule means that suppose at this point, now because it is one wire, so at this point the voltage will be 0 volt. So if I go around this circuit and go once and then come back here, the voltage will be same. Okay, so I start from 0, I gain 10 volts, I lose some volts, I lose some volts, and when I reach here, I'm again at 0 volts. So now let us take an example of, maybe let us say it is 2 ohms resistor and R2 is maybe 5 ohms. Okay, so now let's say that the current flowing is I. So initially the potential is plus 10 volts. You gain 10 volts when you move from this point to this point. Okay, and then as you move through this resistor, you lose 2I of voltage, because it will be, the voltage across this resistor is IR1, and when we go through this loop, then it loses again the voltage, and so it will be 5I, and so this total will be equal to 0. Okay, so it means that 10 minus 7I will be equal to 0. Or if I don't write it like this, it just means that 10 volts minus IR1 minus IR2 will be equal to 0. Or in other words, the total potential difference across a loop is equal to 0. Now, why are we calling it conservation of energy? Because if at this point, when we go once, we start with 0, and when we come back, it is 0 volt. So it means that delta V is equal to 0. Okay, the whole potential, the total potential when we go around is 0. Now you know that potential is equal to charge into potential energy. Okay, so it also means that the total potential energy will also be 0. So at this point, if some charge has some energy, let us say E, and when it goes, it gains energy, loses energy, loses energy, and when it comes back here, it should have the same energy. Okay, so that is why we say it is conservation of energy. It can never gain energy. Whatever energy it has, it will all lose it and again come back here with the same energy. If it is 0 volt, it means that it will have an energy of 0 joules. So when the charge will come back, it will have energy of 0 joules. Okay, if it has, suppose that this is not true and it has some energy, so it will mean that once you move around the circuit, you gain energy, and you go again and you gain energy, and you go again around the circuit, you would gain energy. But this is not true. Okay, so it means that when you go around a circuit, you don't gain energy, because then if it would have been true, then we would have used that energy in other applications, and this would be an easy source of energy. But this is not true. Okay, so when you go around a loop, the total change in energy is 0 and total change in potential is 0.